Chapter 8, Lesson 3, Define and Use Zero and Negative Exponents. So negative exponents, we're going to get into, and also zero exponents today, because there's some important rules regarding those. So let's just look at these right now. Any number, could be 2, could be 5, could be 112. Any number to the 0 power is 1. All of these are equal to 1. The only number that this doesn't work for is when you have 0 to 0 power. That we're not going to get into, but that's just a rule. That's the only exclusion to this rule. Every other number, it does not matter if it's negative 5 to the 0 power, it's still equal to 1. So that's the first rule that's important. Second rule that's important is if you have any number to the negative power, like these here, you can switch this around and you can make it into a fraction. So this one would be, up here this would be, that's how we'd represent that as an expression with positive exponents. That's how we do that. And these are just the reciprocal. If it says here, x to the n is the reciprocal of x to the negative n. Again, that just means that, remember, the terms reciprocal, 2/3 and 3. Those are reciprocals. But this to the negative 1 power is equal to that, because you're basically flipping the two. So that's where we're going to start, and now we're going to start going over some problems. So let's look at these quickly here. So this one here, that's just 1, because it's to the 0 power. This one here, if we were to represent this as an actual fraction, as with positive exponents, we'd do it this way. That's the first thing we do. But if we were to represent this also as just multiplied all the way out, this would be negative 5 times negative 5 times negative 5 times negative 5, which would actually be positive in the end, but it would be 1 over 625. For this one here, 1 over 6 to the negative 2 power. Now that one's a little bit trickier because you've got to flip it around. So it's actually going to be 6 to the positive 2 power, so it's just going to be 36. This one here, you just got to flip it. It's going to be 2 over 5 to the 3rd power. So that's going to be 8 over 125. Now these ones here, it still is with negative exponents. You're just, when you're multiplying, you're adding the 2 exponents, so it's going to be 13 to the 2nd power for this one here. And the rules are the same with subtraction. So this is going to be 8 to the negative power, 5 power, divided by 8 to the negative 5 power. That one should be pretty obvious because it's just the same number divided by the same number, so it's just going to be 1. But if you want to think about it, it's going to be 8 to the negative 5 power minus 8 to the negative 5 power, so that's just going to give you 8 to the 0 power, and that's where we get the 1. 1 to the 1 over 9 to the negative 2 power, that's going to be 9 to the 2, because we're flipping it, because it's a negative exponent, so that's just going to be 81. This one here still is a multiplication problem, because it's negative 2 to the negative 4th power, and then to the that whole thing to the negative 2 power. So I'm just going to multiply it out. It's going to be, now it's going to be negative 2 to the negative 8 power. Then I'm going to flip it. And now I got to figure out what negative 2, or 2 times 2. 2 times 2, 4, 8, 16, 32. That's 1, 2, 3, 4, 5, 6, 7, 8. So that would be negative 2. It's an even number, so it would be 1 over 256 would be the final answer for that one. We'll just clear this out to get a little bit more room here. negative 4 to the 7 power times negative 4 to the negative 9 power. So that's going to be, just going to add the exponents. Now we're going to flip it. Now we're going to multiply it out. And same thing here, except for in this case here, 10 to the negative 2 power, or 10 to the 2 power. And then you're going to subtract the negative 3, so it's just going to be 10 to the 5th, which would just be 10, 1, 2, 3, 4, 5. And we're done with that part. Same rules with regards to variables. So you're going to distribute the 3 for this one here, this problem here. It's a little bit hard to read, so I want to make sure you got it. So this problem here, it's 3m to the negative 2 n to the n to the third power 3. So we got to distribute that 3 on the outside first. So this is going to be 3 to the third, m to the negative 6, n to the ninth. So when we do that, that's going to be 27, n to the ninth, and we got to put that m to the sixth on the bottom. So that's how we'd represent that. This is how you'd represent that using only positive exponents. Let's try this other one here. So this is going to be negative 5xy to the second power, y to the negative fourth, over negative 10, x to the third power, y to the negative 8. So there's going to be a whole lot of moving around of these. So I'm going to use a lot of space here. So first of all, I'm going to get rid of this part here. I'm going to distribute that 2. So it's going to be negative 5 to the second power, x to the second power, y to the second power, times y to the negative fourth power. And that's going to be 10 x to the third, y to the negative 8 power. So what we can kind of do here is we can just kind of flip these up and down so that the negative powers are on top. The negative powers, these two y's, we can just kind of flip them because they're both negatives, so they need to be flipped. They need to be on the other side of that dividing line. I'm also going to do a little bit of math in the meantime. So this is going to be 25. Simplifying that negative 5 squared, so x squared, y squared. So I got to put that y to the fourth on the bottom now. I put the y to the eighth up on top, and then it's going to be negative 10 x to the fifth. So I'm going to combine these one last time here. This is going to be 25. It's going to be x to the 10th because, excuse me, it's going to be x squared y to the 10th over 10 negative 10, and then it's going to be x to the 5th over y to the 4th. Now I can just start canceling things out. So this is going to be 25. It's going to end up being y to the 6th over, and then we got this here, it's going to be negative 10 x to the negative 3, because I'm just subtracting subtracting that from there. Actually, let me correct that. It's going to be actually x to the negative 3 on top. And so our final answer here is going to be 25 divided by negative 10. And again, this is a really complicated problem. 25 divided by negative 10. Got to move the x down to the bottom again. Keep the y up there. And then the last step is simplifying that 25 and negative 10 parts, so that's going to be 5, 2, we're just going to leave the negative down there, y to the 6th, x to the 3rd. And that's your final answer.